Welcome to the DWare Black Tech. Now we will see binary to gray code conversion in Xilinx FPGA Spartan 6. We are going to implement that binary to gray code conversion. So first of all, we have to think about the thread table of the binary to gray code conversion. Before that, just see about how the binary to gray code conversion is going to work. Okay, so for that, here we have this the binary format. This is the 4-bit. So B1, B2, B3, B4, and G1, G2, G3, G4. It is the converted output. That is the gray code output. So the that means the MSB bit which remains as the binary. That means G4 equals to B4, and the lesser bits, that means the G3, G2, and G1, they are the XOR of the MSB of the binary and its previous one. Similarly, that previous one and its previous one, XOR of all those things. Here we can see the first one is the MSB, then next one is the B4 XOR B3, then B3 XOR B2, then B2 XOR B1. Like that it will continue for the higher bits also. I think you understand. So by using these equations, we have to write the thread table. So here we have the thread table. This the 4-bit binary to gray code converter. Okay, yeah, so I'm going to show it. Okay, yeah, I think it's visible. It's the binary to gray code converter. So whenever we have 0000, that remains as 0000. Then from here it will going to change. Okay, so 0010, then here 11, then here 0010, like that it will going to change. Okay, depending upon that XOR of B4 and B3, like that it will going to change. Now we are going to write the Verilog code for this, and we have to implement this in the FPGA board. So for that, first of all, we have to go to ISE. That's the ISE tool. Then we have to type again the ISE and go to the new project. Okay, so this is the tapes. Just click OK, then go to the this is the file, but I have to go to the new project. Then here we just have to type what we are going to doing. So BCD to gray, GREY, I think, BCD to gray. Then this is the properties of our FPGA that we have on the board itself. We can see that. Okay, here you can see. I think I have to disconnect it, and okay, you can see these numbers that has to be filled properly in that table. That is the board specific. Okay, board it depends upon which board you are using. This is the Spartan 6, Xilinx Spartan 6 FPGA, so it depends upon that. Then click on next, then click finish. Okay, then yeah, we have our main project window here. Now we have to write the Verilog code, and as well as if you want, we have to write the test bench and then see the waveforms, and then we have to implement. So first of all, I have to write the Verilog code for this BCD to gray. So new source and Verilog module. No, not this. Yeah, Verilog model. And here I'm going to call this as BCD to gray. Then just click on next. Then click finish. Okay. So for the time being, I have the code here. It is a very easy code. Just we have to make the XOR of all those things. Now we are going to implement that same using the this vector. Okay, vector. That means the 3:0. I think you know that how it is going to write. Like it is the mainly the concept of the arrays. So 3:0 of G means G0, G1, G2, G3. So in the thread table, I think that means in the expressions we took as B4, B3, B2, B1. So while implementing this, we just take like B3, B2, B1, B0, because in that we forgot the not 0. So it's better if we consider the 0, 1, 2, 3 like that when we come to the digital logic. So now I just have to okay, I just copy this code and I will explain this. It's very simple. So Okay, this is the BCD to gray. I have BCD to gray. Okay, now here we can see okay, these things are not necessary. Yeah, this is the B3, B2, B1, B0 to G3, G2, G1, G0, and G3. Here we can see G is 3:0 of G, that is the output, and here we have G and the B, that is the port declarations. Then here we have, okay, G of 0, that is B of 1 XOR B of 0. So here we have B of 1 XOR B of 0, then G of 1, that is B2 XOR B1, B2 XOR B1, yeah, G3 equals to B3, so G3 equal to B3. Here we are using the data flow modeling, so we have to follow like assign keyword, then whatever the output we want, that means the port, the output port, then the expressions, like that we have to follow. So that's it, and module. Now we just have to write the pin configuration for this output and the input. Okay, so for that, here in the FPGA we have the 4 DIP switches that we just use as a input, that means the binary code input. Then the output, that is the gray converted code, that one we will going to see in the those LEDs. So for that, for the pin configuration, we just have to click here, and that is called as the user constraint file, or okay, yeah, where is that new source or implementation constraint file. So here I just call this as pinout, then click finish. Okay, so now this pin is like, it is the address for those input and output pins, and it's the board specific. Along with the board, you have the board manual, so just refer for these pinouts. So I have here, okay, I have, yeah, this is the DIP switches, like this you have in so it depends upon the board. Then for DIP switches, we are going to use 4 DIP switches, 0, 0, 0, 1, that means 4, B0, B1, B2, B3. So for binary, these 4 we are going to use. Then, okay, I just have to copy that here. This is for the input and output. We are going to use the 4 LEDs, that is okay, the middle, these 4 we will going to just use. So this is LD2, LD3, LD4 and LD5. Okay, so middle 4 LEDs we have to use. So for that LEDs, that is from 2, okay, 2, 3, 4 and 5. Control C, and yeah, so here this is we just have to look here what is the our output and the input variables, that is the B and the G. Okay, B and the G, B is for the input. So in the pinout also we just have to okay, here it is the G, because not here. Okay, here we have to write instead of TL, this is G. Okay, then G, and here G0 and G1, G2 and G3. Okay, I think it's visible. And here instead of this we have to write B and B0. Okay, B0, then okay, I'll just write this B1 and B2. Oh, I think it's not like this. Okay, B1 and B2 and B3. Okay, B of 3. Yeah, now it's okay, this is the output, and this is the input, InputOutput. I think only 4 inputs and the 4 outputs. Yeah, binary is 4-bit and output is the gray code. Okay, now we just have to save this, and just go to here, and then click on this, manage configuration projects. So this will going to check for the that means it will going to synthesis, and after that generating the programming file. Then after that it will going to open the configuration of the project window. So if any error is there, that is going to show now. I hope there is no any errors. Let's see. Okay, yeah, it is configuring. Implemented design is successful. Then generating the program file. Yeah, it's successfully generated and opened. Just click on the boundary scan and initialize chain. Then we just have to upload. Click on S and here projects. Then what's the name that we give? That is the, I think, BCD underscore gray. Yeah, this one, BCD to gray. This is the .bit file extension that you just have to add .bit. Okay, then click this no, then click on OK. Then yeah, here we have our board. Let's see now. So I just have to program this now. Okay, I think yeah, we have to reprogram. Okay, this is the reset button. I just reset it and we'll just hit program again. No, then okay, yeah. Boundary scan, initialize chain. Okay, now click yes. I think that is the same directory, that is BCD to gray. Okay, the same thing. So here go to projects and BCD to gray, this bit file. Okay, then click no. Here click apply and click OK. Then just start to program this. Okay, we will just check it now whether it's coming. Okay, sometimes like this it will happen. What we have to do means we just change this from this DIP switches to this push buttons, the address. Okay, then we will try. So let's go to the pinout and here instead of this okay, binary to gray, the output is the input, we just use the push buttons. Okay, so and we will check b of 0 and yeah, I will just copy that, b of 0. Okay, then here we have to b of 1, b of 2 and b of 3. 1, 2 and 3. We'll just comment these things. Okay, now we just again generate the programming file. Okay, yeah, this one directly I will give manage configuration project, and here we just disconnect and connect it. Let's see now. So this is all at 0 0. I'm just making this to I think no, I'm just making this to 1 1 1 1 1. Okay, this is the default program. You have to upload it. Okay, now all these things are at 1 1 1 1. So it is generating. Yeah, let's see now. Oh, it is giving project like this. Okay, this is okay. Yeah, boundary scan. Okay, now we will check it. Yes, and now we are not using this. We are just using this. Okay, now we will see proper and BCD to gray bit file. Then this no, then okay, I just have to program this now. Yeah, now it's working. Here you can see, yeah, Now this working, this all at 0 0, so all these LEDs are 0 0. Now if I make I think this is the LSB bit, so if I make this, then okay, then we are getting the one here. We just compare that with this table. So yeah, okay, I'll just move like this, then not this one. Yeah, we'll just compare with this table. So 0 0 0 0 and all are 0. When 0 0 0 1, then this is 1, and 0 0 0 0 1 0, then we have this, okay, 1 1 0 0 1 1 0 0 1 1. Then yeah, we will just check at 1 1 1 0. Okay, so this is 1 1 1 0, that is 1 0 0 1. I'm just pressing these three buttons, last three buttons, so that is 1 1 1 0. Then that is okay, I just have to press all, then 1 1 1 0 is 1 0 0 1. I hope you understand. So now if sometimes due to some issues it will not going to give as we seen just before, so just try with changing the DIP switches to the push buttons and again reverse it. Now we just change that to the from the push buttons to this DIP switches, then we just look at this. Now I just comment this DIP switches, no, not the push buttons, and I commented that means the these are now considered, okay, that is the switches. So now we just manage configuration project, and okay, this is like here, it is just like here, it is generating. You can see the output is coming. This is the previous one. Due to this push buttons, now we have to using this, okay. So you can even use these GPIO ports for input and output when we have to connect these BCD to gray code output to some other applications, okay, then you can use these GPIO ports. So for that also similar address is there, you just have to use that, that's it. And in this board, these two are the ground and these two are the VCC, okay, last these two are the VCC and this ground, and it's basically working on 3.3 volts. The complete board is working on 3.3 volts. Boundary scan, then initialize chain. Okay, now this is yes, and okay, here I have BCD to gray, open, then just click on this node, then okay, then okay, I'll just keep this open here, this I program. Yeah, now it's working, it's 1 1 1 1. Now if I make 0 0 0 0, all are zeros, so if I make 1, then that's 1. Then if I make here you can see, if I make 1 1, then that is okay, it's 1 1 now, 1 1, then this is okay, one LEDs, we just have to compare that with this one. So here whenever this is 1 1, that is 0 0 1 0, so only one is growing, 0 0 1 0. Then if I make all are 1 1 1 1, okay, if I make all are 1 1 1 1, then here we can get the MSB bit as a 1. So 1 1 0 1, okay, 1 1, then 0 1, okay, this I just make. Then here we can see the 1 0 1 0 1 1. So what's that? 1 1 0 1. So 1 1 0 1, that is 1 0. Oh, I think I just make it this reversed. That means this I made. Okay, we just see this is a 1. This is the LSB. So I just have to make okay, this one 1 0 1 1. So 1 0 1 1, 1 0 1 1. then I'm getting 1011. So for this one, okay, 10 for this one, 1101. Okay, so for this one 1011 I have to get, so 1011 I'm getting. I think you've understand this binary to gray code conversion. Thank you.